All right, hi guys. Tonight we're going to review factoring from last year, and we're going to look at two types of factoring. One type is where the leading coefficient of x squared is 1, and type 2 is where the leading coefficient of x squared is bigger than 1. And I'm going to use the same procedure I did last year, where we're looking for factor pairs that add up to the middle term. And then we're also going to check our answers. And there's one more type we're going to take a look at the difference of squares. So let's go ahead and get started with our review of factoring from last year. Okay, so type 1 is x squared plus bx plus c. This is standard form of a polynomial, or of a quadratic equation, sorry. So we have our leading term here, which is a degree of 2, that makes it a quadratic, then b times x, and then c. And so this is where we're assuming that x is bigger than 1. Or x is not equal to 0. So our coefficient here is just 1. So the coefficient in front of the squared term is 1. To factor a trinomial in this form, you need to find the two numbers that have the sum of b and the product of c. So in our example, we are going to factor x squared plus 7x plus 12. So what we need is the factor pairs of 12 that will give us a sum of 7. So I have my factor pairs of 12. Of course, there's 1 times 12, there's 2 times 6, and there's 3 times 4. Which of those factors will give me the b, the sum of the coefficient of the middle term, will give me a sum of 7? So if I look at 1 plus 12, that gives me 13, so that's out. 2 plus 6 gives me 8, so that's out. But 3 plus 4 gives me 7, and that makes me happy. So the factor pairs of 12 that add up to 7 are 3 and 4. And that's it. We're done. So when we want to write that as a pair of binomials, our variable is x. So we have x plus 3 and x plus 4, and that is equal to x squared plus 7x plus 12. How can we check our answer? Well, we're going to check our answer using the box method. So we'll put x plus 3 here and x plus 4 here. X times x is x squared, x times 3 is 3x, x times 4 is 4x, and 3 times 4 is 12. So we have x squared plus 7x plus 12. So what happens if... Okay, so go ahead and try these two and then check back for your answers. Factor each expression, and remember to check your answer using the box method. You can use the FOIL method. I don't like the FOIL method. Or you can use the distributive method, and that's fine too. And we have different variables here. In number 1 we have v, and in number 2 we have a. So I'm going to pause the video, write the answers, and then you can go ahead and check back. Okay, so here's our answer for the first one. We need factor pairs of 20 that add up to 21, and we have 1 and 20. So our factored form for this polynomial is v plus 1 times the quantity v plus 20. And so v squared plus 21v plus 20 is equal to v plus 1 times the quantity v plus 20. Okay, so our factor pairs of 30 that add up to 13. 3 times 10 is 30, 3 plus 10 is 13, so it's a plus 3 and a plus 10, and that equals a squared plus 13a plus 30. So if we check our answer right here, a times a is a squared, there's our a squared term, then we get 13a here, and we get plus 30 right there. Okay, so let's take a look at type 2. Is now bigger than 1, so we'll have to consider both factors of both a and c. So let's take a look at example number 1. So we can't just find factor pairs of 3 that add up to 17, because that's not how this works. So before you do anything, is there a greatest common factor? If the answer is yes between each term, then factor it out. If not, then we're just going to work below, and today we're not going to deal with common factors. So here is our example, 10x squared plus 17x plus 30. So now we're still looking for factor pairs, but now we're looking for factor pairs of 10 times 3. So 10 times 3 is 30. So we need factor pairs of 30 that add up to our middle term of 17. So factor pairs of 30 that add up to 17 are 15 and 2. So 15 times 2 is 30, and 15 plus 2 is 17. So we can start to write our factored form. We have x plus 15 and x plus 2. But we have to consider the fact that we multiplied the 10 times the 3. So since we multiplied it in to get 30, we need to factor it out of the second term. So we are going to divide that second term by 10. And when we simplify this, the fractions, what we end up with is x plus 3/2 and x plus 1/5. So we can't leave that as a fraction, that second part of the term in the parentheses. So this is what we did. The 2 comes up here. So we get 2x, leave the 3 alone. The 5 comes up here, and we get 5x plus 1. So we get 2x plus 3 and 5x plus 1. So again, we want to check that to make sure we did that right. So 2x and plus 3 and 5x plus 1. 2x times 5x is 10x squared, so there's our 10x squared term. 3 times 5x is 15x. 2 times 1 is 2x, so there's our 17x, and 3 times 1 is 3, so it checks out and makes me happy. Go ahead and try example number 2. There is no example number 2, so don't try it at all. The last example we're going to look at is the difference of squares. So what does that mean? So difference means that we have a subtraction problem. So here's difference, which means it has to be subtraction right there. And squares means that the first term and the last term, make that a little bigger, sorry. The first term and the last term are squares, perfect squares. X squared is a perfect square, and 9 is a perfect square. Because x squared is the same as x times x, and 9 is the same as 3 times 3. So this makes our job a little bit easier. So when we want to factor this, it's the square root of x squared plus the square root of 9, the square root of x squared minus the square root of 9. And what that gives us is the square root of x squared is x, the square root of 9 is 3, and the same thing here. So we end up with x plus 3 and x minus 3. So let's go ahead and check, make sure we did that right. So we will check, or I will check, using the box method. And we have x plus 3 and x minus 3. X times x is x squared. 3 times x is 3x. X times negative 3 is negative 3x. And negative 3 times positive 3 is the negative 9. These two end up canceling each other out. And so we get x squared minus 9, which makes me happy. Okay, so here we go again. Multiple choice question number 1, you need to factor d squared minus 14d plus 49. Keep in mind that the leading coefficient is 1, so we just have to find the factor pairs of 49 that add up to a negative 14. And number 2, factor the difference of the squares problem. 9 is a perfect square, x squared is a perfect square, and so is 16. So you need to find the square root of 9, the square root of x squared, and the square root of 16. Please be sure to put your answers in the Google form and ask if you have any questions. Have a good night.